We present our work, Paint by Inpaint, learning to add image objects by removing them first. Our goal is to add objects to images, specifically with the use of textual instructions, while maintaining source consistency. This is a bad example, and this is a good one. One of the most successful image editing approaches is Inpainting, where any image can be used for training given an input mask. A diffusion model is conditioned on the masked image and trained to predict the original image with textual guidance. Unlike in painting, there is no available data for mask-free instruction-based editing. The current approaches for building such a dataset suffer from several drawbacks, which include lack of source target consistency and the use of non-natural synthetic images. In this work, we build on the following insight. Removing objects is significantly simpler than its inverse process of adding them. Removing is simpler since objects' masks can be used, while adding is more complex as no mask exists for the new objects. Given this insight, we used an high-end Inpainting models together with masks datasets to build pairs of images with and without objects. We then used this dataset to train a diffusion model to inverse the Inpainting, thereby learning to add objects. Inpainting models are not trained specifically for object removal and can leave original object traces or generate a new undesired objects. Therefore, we designed a dedicated removal pipeline, composed from a pre-removal, removal, and post-removal steps. See our paper for more details. To create a rich object edition textual instruction, we use VLM to extract the object information and an LLM to translate it to an instruction. These are examples of our final mask-free instruction-based dataset named Pipe, which consists of natural images with source target consistency by construction. This dataset is then used to train an editing diffusion model, which learns to add objects to images. These are editing results of our trained model. We can see how objects are naturally added to images while maintaining source fidelity. We compare our results to state-of-the-art editing methods, showing our superiority. This is examined qualitatively, quantitatively, and by human evaluation. Our model can be also used for multiple object addition. However, we use a latent diffusion model, which requires sequential decoding and encoding, which causes cumulative degradation. To solve this, we perform all the editing on the latent space, resulting in high-quality editing. These are two multi-steps editing examples using our models. To summarize, we propose Paint by Inpaint, a novel framework to build a large-scale, high-quality editing dataset, which leads to state-of-the-art object edition results. Please visit our project page for more information and for our dataset and models.